All right. Welcome, everyone. We're going to go ahead and start today's interactive virtual field trip brought to you by Learn Around the World. If you've never been on a Learn Around the World virtual field trip, this is an interactive experience. You can send in your questions if you're on camera or off camera today. Just use the Q&A app built into the bottom of your Zoom window. Or alternatively, teachers, you can also use Twitter. So if you're a Twitter user, just make sure you use the hashtag GEOshow to text in your questions. I am only following the hashtag GEOshow, so do not at me. Also, log into Kahoot and play along using Kahoot today with our quiz and survey questions. Today's game pin is 228-3145. That's also located in your chat box, teachers. Explorers, pay attention. If you win today's Geo quiz at the end of the show, you'll win a postcard from me, GeoB, from the Learn Around the World studios. All right. Also, if you stump me on any questions, I don't know everything there is to know about volcanoes. If I need to do further research, I'll go ahead and find those for you and post those over at flipgrid.com/GeoShow. All right, it's that time of the day. Explorers, are you guys ready? All right, everyone, welcome to today's Geo Show brought to you by Learn Around the World. And our topic today is volcanoes of Guatemala. We're kicking off today's show with our first survey question. If you've never used Kahoot here on the Geo Show, we only give you 10 seconds to answer, not a lot of time. Don't worry if you're not logged in yet. This first question is a survey question, so we're not giving out points yet. We're just practicing. So you must look up at the screen to see the questions and the answers where you see me right now. All right, we're going to go ahead and practice using it. And here we go. All right, today's first survey question is, we're going to Guatemala. Where is Guatemala? Is it located in red Asia, blue Africa, yellow South America, or green Central America? All right, it's located in Central America. If you said green, virtual high fives to you. But let's find out. If you don't know where Central America is or Guatemala, let's go ahead and check out the map. You are watching the Geo Show. We're a geography-based program. That means location matters. And if we spin our big blue ball around, let's go ahead and zoom into Central America. All right, we're going to freeze it right there to point out Guatemala and its neighbors. So highlighted in red here. This is the country of Guatemala, and Guatemala has many neighbors. They are to the north and northwest. Here we have Mexico. To the east, we have Belize. To the east, southeast, we have Honduras, and south of Honduras is El Salvador. Those are the bordering countries to Guatemala. All right, and Guatemala, why are we talking about volcanoes with Guatemala? Well, it's one of the countries located along the Ring of Fire. And because of that, there's many volcanoes. There's about 37 of them located in southern Guatemala in their mountains. And we're actually going to hike up an active volcano today. And that's why it's a great place to study volcanoes. Some of the areas that we're going to look at is Antigua, which is the old capital city of Guatemala, surrounded by volcanoes, and Volcan, which is an active volcano that we're all going to virtually trek up today. So those are our locations that we're talking about on our program. We're going to have several vocabulary words we're going to learn today. And our first one, or our first phrase here, is going to be the Ring of Fire. Can you guys say Ring of Fire?
Ring of Fire!
Okay, so the Ring of Fire is an area that we call around basically the Pacific Ocean, where the Pacific Ocean meets land. And we call this the Ring of Fire because 90% of all earthquakes happen somewhere along the Ring of Fire, and 3/4 or 75% of all volcanoes happen along the Ring of Fire somewhere. Okay, so it's an extremely active area of the world for earthquakes and volcanoes. If you want to focus just on the US, about 3/4 of all volcanoes occur in Alaska, which is again located on the Ring of Fire. But why? Why is the Ring of Fire so active? It's active because of a process called subduction. Subduction. What's it called, guys? All right, so subduction. Don't forget this, but subduction is the main reason or the main generator, the main engine of all of these volcanoes. So let's talk about subduction and how that process works. So first of all, we need to think about the Earth, and around the entire Earth on land and underwater, under all that blue stuff, it doesn't matter. All around the Earth is a hard surface. It's called the Earth's crust. And the Earth's crust is not one solid piece. It's not like a marble. It is broken into what we call plates. And we call this plate tectonics. Plate tectonics is how these plates move around and interact with one another. If you want to think of it like a 3D puzzle, and these puzzle pieces are moving, some of them are moving into bumping into each other. Some of them are moving away from another. Some of them are slipping side by side across from one another, just rubbing shoulders. Hey, how's it going? But because of these interactions, they cause things like earthquakes and volcanoes and all sorts of things. And the process of subduction is when you have two of these plates that ram into each other, and one of them is heavier and one of them is lighter. So sometimes if you have two light ones, like two continental ones, this is when like India bumps into Asia, it creates the Himalayan mountains. But in this case, around the Ring of Fire, we have something called subduction. This is when we have the heavy Pacific crust bumping into land. In our analogy today, we're talking about Guatemala, but you can think of Alaska, you can think of California, for example. What's happening is we're all going to do this. So everyone take your two fists. We're going to fist bump ourselves here. And what we're going to do is we're going to fist bump ourselves. And I want you to take your left hand and you're going to go under your right hand. So our left hand is the Pacific crust. That Pacific crust is going down deep into the earth. And as that Pacific crust goes down deep into the earth, that crust is melting. It becomes molten magma. And that molten magma makes its way up and causes volcanoes. So let's look at an illustration of that process. We love fist bumping ourselves, but here's what we have. If we look with our eyes, starting on the left-hand side, this is the Pacific Ocean. The Pacific crust is going below Guatemala in this example. And when that hard rock gets deep into the earth, that hard rock melts just like an ice cube melts. It goes from a solid to a liquid. Well, hard rock, if you get it hot enough, it will go from a solid to a liquid called magma. And that molten rock will eventually make its way up. In this case, in Guatemala, let's say Pacaya, for example, the volcano we're going to hike up, it makes its way up into vents. And when enough pressure builds up in that volcano, well, one day it will erupt. And when that magma comes out, it becomes lava. So when it's in the earth, we call it magma. When it comes out of the earth to the surface, we call it lava. When it's in the earth, what do we call it?
Lava!
And when it erupts to the surface, what do we call it?
Lava!
Oh, lava. You guys are doing great. Okay, so that is basically the process, the engine that is causing all of the volcanoes that we find in places like Alaska, Japan, Indonesia, and here in Guatemala, all around the Ring of Fire. And we have about 37 volcanoes in southern Guatemala, and a lot for such a small country. All right, so before we start hiking up Pacaya, we do want to give some shout outs. Our first shout out today goes to Grays Creek Elementary School from my home state, North Carolina. Big shout out to everyone watching from North Carolina today. We also have several on-camera guest classrooms, and if you are with us and you have a fun fact, send them up to the camera. Next random shout out is going to Pickerington Local School. It's a lot of syllables in Ohio. Big shout out to everyone watching from Ohio today as well. All right, first up, we have Mrs. Worski's 4th and 5th graders from Anaheim, California. Welcome to the show, guys.
Hi!
All right. Do you have a fun fact you would like to share about volcanoes today?
Hi, my name is Manira, and I learned that volcanoes have lots of states like a lava fountain or lava lake.
All right, so Lava Lake. So anyone seen Kilauea on the news recently? Yeah, okay, so Kilauea has the second largest lava lake in the world on top of it, so really neat there. Next up, we have with us today Mrs. Borgiorno's second and third graders from Richmond Hill, Georgia. Welcome to the show, guys.
Say hi, guys.
All right, and do we have any fun facts from Georgia today?
Gracie, I'm here. Gracie, go tell Mr. Brandon your facts.
Okay, real loud for us.
Real loud. Scooch over. Scoot over. Let's get it. Scoot over. The other way. We're learning.
Go for it, go for it.
We're learning about volcanoes.
Yeah?
Tell your facts.
When a volcano is not active, it's very peaceful in the area.
All right, it's very peaceful. And we call a non-active volcano a dormant volcano. What do you call it?
A dormant volcano.
Awesome. Thank you for your research. That's so amazing, guys. And last but certainly not least, we have Mrs. Morse Rose classroom, third graders from Orange, New Jersey. Welcome to the show, guys. Hi, guys. And do you guys have any fun facts you would like to share with us today?
Believe.
Here.
Go for it.
Go ahead, say it. Say it.
Some rocks are from volcanoes.
Some rocks are from volcanoes?
Many are.
Awesome. So we call these, for everyone out there today, we call these igneous rocks. Can you say igneous rocks?
Igneous rocks.
So igneous rocks are rocks that are formed from magma or lava. So if it cools inside the earth, we call these intrusive. If it comes out of a volcano, like lava, for example, those would be extrusive igneous rocks. So thank you everyone for your research. If you've been studying volcanoes and you would like to share it with all the explorers out there, go to flipgrid.com/GeoShow. Share your fun facts with everyone over on our volcanoes board. But we're jumping right into it today, guys. We're going to hike up an active volcano, and we'll give another shout out to Wyndham and Raymond schools in Maine. Shout out to everyone up in Maine today. All right, so let's get right to it. We are going to Guatemala. I hope everyone brought their virtual passports today because we are headed to hike up an active volcano. Before we do, we have another survey question. So grab your devices if you are playing along today. We just heard from one of our fun facts that's about active and dormant volcanoes. So our next survey question has to do with active and dormant volcanoes. So go ahead and grab your Kahoot devices. And that question is, does a volcano need to be erupting to be called an active volcano? So does lava need to be coming out of it to call it an active volcano? Yes, no, or I don't know. Okay, so if you said blue, no, you are correct. Lava does not need to be coming out of it to be called an active volcano. We can classify volcanoes into 3 groups. That's right, 3 groups. And those groups are active volcanoes, dormant volcanoes, and extinct volcanoes. So the first one is an active volcano and a dormant volcano second. The third is extinct. Let's start with extinct. Extinct volcanoes are easy to think about. It's just like if an animal goes extinct or a plant goes extinct, we're never going to see them on Earth again. Well, if a volcano goes extinct, the shell, the actual mountain itself, the volcano will still be there, but it will never erupt again because there's no more magma coming up into the volcano. That's why it is extinct. The other two are a little bit more difficult to think about for us, and that's because an active volcano is a volcano that has erupted at least once in the past 10,000 years. A dormant volcano is one that has not erupted in the past 10,000 years, but we think it will erupt again someday, or it has the potential to erupt again someday. And I know what you're thinking. Hey, GOB, how can we call a volcano active if it hasn't erupted for 8,000 years? That doesn't sound very active to me. Well, we need to think about Earth years, not human years. Earth years, not human years. The Earth is 4.6 billion years old. 10,000 years is not a lot of time. When you start thinking about billions, that is a huge number. So in human years, yes, maybe it's not very active to us, but when we start classifying volcanoes that can be very, very, very old, then yes, it is just a short amount of time. Okay, so we're going to hike up an active volcano, and don't worry, it's more active than thousands of years ago. Just not too long ago. All right, so we're going to hike up Volcan Pacaya. And we call it Volcan Pacaya because we're saying it in Spanish. That's what they speak in Guatemala. It's located about 30 kilometers south of Guatemala City, the capital of Guatemala. And we're going here next, Antigua. So Antigua is just a little bit northwest of Volcan Pacaya. All right, so let's do it, guys. Well, we're going to start off with our virtual exploration of Pacaya at the visitor center. We'll hike up through the forest on the side of the volcano, and then we'll come out and explore the lava fields. So what we're looking at here is the lava fields. So all this black stuff that you see just looks like a shadow. That's all lava rock from the 2010 lava flow. So a little bit less than 8 years old now. And then when we turn around, we can see Pacaya, and we'll be able to see Pacaya. And Pacaya is something called a stratovolcano. Can you guys say stratovolcano? Okay, so a stratovolcano is very typical. So most of the volcanoes around the Ring of Fire are stratovolcanoes. These are these big, tall, cone-shaped volcanoes. And the way that they occur is they start off small, and as they, over many, many eruptions, they leave layers of ash and lava, ash and lava, ash, ash and lava, ash and lava. And as it grows bigger and bigger and bigger, it gets steeper and steeper and steeper, and it will make a very steep cone-shaped volcano. And this is, you know, when we think about volcanoes, we make them in science class with baking soda and vinegar, maybe for a science fair project. We typically make like a stratovolcano. We like those big cone-shaped volcanoes, right? All right, so Volcan Pacaya is pretty young. It's only about 23,000 years ago was the first eruption, and it is 8,373 feet tall. All right, so we're going to head out to the visitor center, and abracadabra, we're now in Guatemala. We're going to meet our tour guide first. Tour guides are going to point out where we're going to hike to, point out the safe areas and unsafe areas to stay away from. And we'll start hiking from the visitor center. Very quickly, you can see that the soil turns black on the volcano. And when we look here, the soil is very dark on the ground. And if we freeze it right here, if we look here, very, very dark soil. And do we have any guesses? What would make that soil so dark? Let's start in New Jersey this time. What do you guys think?
The lava.
Okay, so the lava. So it could be, definitely there could be chunks of lava, and there definitely is in this ground. And I'm thinking of something else that comes. Have you guys ever made a campfire before?
Ashes.
All right, ashes. There you go. Boom. So ashes. So I want to really touch on this today, guys. Is, you know, a lot of times we focus on lava. Obviously, that is an extremely dangerous part of a volcano, especially for humans. But the ash is more disruptive. Yes, I'll say that. The ash is more disruptive typically for people living near volcanoes than the actual lava. And we'll talk about why that is. And part of that is because ash, just like a campfire, can float up in the air, go a very long distance before it comes back to the ground. Well, a campfire just puts out a little bit of ash. Imagine how much ash comes out of a volcano. A lot. And so sometimes, in the case of 2010, which we'll learn about just in a few minutes, it covered some parts of the volcano with 3 feet of ash. Can you imagine 3 feet of ash, guys? So we're going to stop at this overlook, and that's kind of a hazy day, but we're still going to look out here because I want to point down to the community here. So here's a community that's near Pacaya. It's not, you know, right up by the caldera, so not up near where the lava would be. However, this is an example of a community that would be really affected by all the ash coming out. Even, remember I pointed out Guatemala City, 30 kilometers away, even Guatemala City could be blanketed with ash, and it has been from Pacaya. It can shut down plane travel and all that stuff. Cool thing about this community is they live close enough to Pacaya that they can actually just dig a hole in the ground and bury things like meat or vegetables and just cover up that hole, and no fire is required. It's like a natural oven, so you can cook food just by digging a hole in the ground because of the heat from the earth. How cool is that? And keep that in mind, that heat from the earth, because I'll show you something else at the end of our hike, another cool thing that humans can do with that heat. All right, so if you notice on each side of the trail here, it's lots of vegetation. So we're in a tropical part of the world. It's very hot, very dry during the dry season. They have two seasons in Guatemala. They have a dry season and a wet season, and it's very wet during the wet season. And because we're in a tropical area of the world, we get tropical fruit. So on the way up, there's rest stops that locals come here to sell fruits. Like mangoes, papayas, bananas, for example. And if you've never been to a tropical area of the world, I highly recommend it. But the kinds of bananas that you eat are not the same that you buy in your grocery store. Only one kind of banana can really be shipped halfway around the world. And speaking of food, does anyone need to use the bathroom? No? Okay, we'll continue on. All right, we'll just hold it to the end. Okay. All right, so I don't say I didn't give you opportunity. All right, so on each side, you see all this lush vegetation. Here's another rest stop. And remember, I was telling you about the ash. So this area, this very spot that we're looking at here, this was covered in 3 feet of ash. Can you imagine? So from some of our schools, it may be from northern states in the US today, or even Canada, you may have seen 3 feet of snow before, or a meter of snow. Can you imagine 3 feet of ash? That's just really messy, especially if it rains afterwards. And this happens sometimes. So when you have a bunch of ash and then it rains, it makes this really kind of soupy, this kind of mud, this ash mud, and just gets all over everything. It gets in car engines and really just really disruptive to humans' day-to-day life. All right, so on the way up, our tour guide actually stopped to start cutting some sticks and branches from trees. We're actually going to use these in a few minutes. You can guess with your partners to your left or to your right, what do you think we're going to use these sticks for? I won't tell you just yet. I'll wait to show you, but it's pretty cool. All right, so as we get to the end of our hiking trail, lucky you guys on a virtual field trip and a virtual hike up an active volcano, you don't have to go through the past 2 hours of hiking. We're going to go ahead to the end and we get to see our first shots of Pacaya. So Pacaya, again, is a stratovolcano. And when we look at Pacaya, I'm going to give you 2 dates today. And to remember, okay? So one of them is 2014. So 2014 was the last eruption. When was the last eruption, guys? Okay, 2014. But the lava that we are going to check out, because 2014 lava flow went a different way. This eruption right here was bigger than 2014. This was from 2010. This number is important because this means the lava that we're going to walk on here that flowed down, you can see where it's darker. So here's like the lava highway here, and you can see where it flowed down and started to spread out. And this lava flow, all of this lava was from the 2010 eruption. That eruption lasted for 20 hours. And when we look across the lava field from that 2010 eruption, we're going to point out a couple of things. First of all, there's some people down here. We're about to be some people down here too, but look how small they are. They give you an idea of how high up we are right now. But I want to point out this shack right here. So this is something called the lava store. Say what? That's right. There is a lava store up here. But here's something really interesting to think about. The lava store used to be located over here, but the lava store is now over here. Do we have any guesses of why that is so? Let's go over to Anaheim. What do you guys think? Right. So I heard a lot of answers as because of the lava, and you are correct, because all of this lava, all this dark area, this was the lava that was spreading out. So it was moving this way. Now they had time to move it because lava moves pretty slow when it gets down to a flat area. And so they did have time to move it, and they moved it out of the way to save the lava store. And this is a great time to talk about lava because, you know, usually when we see movies and you think, you're like, run, lava's coming, right? And but there's a difference in lava. Not all lava is the same. And so, for example, when we talk about Kilauea that you see on the news right now, in Hawaii, for example, the lava gets a lot hotter. It gets over 2,000 degrees Fahrenheit, and it can, when it gets that hot, and it has it's made up of a little bit different minerals in that lava, and it flows a little bit. It's a little bit more viscous. It means it flows a little easier, and it flows like honey. So if you think of like the side of that stratovolcano, if you had honey pouring down, it would go really quickly. It would move pretty fast. But in the case of Guatemala and other places around the Ring of Fire, that lava tends to be not quite as hot, somewhere anywhere between 1,200, 1,400, 1,600 degrees. And that has a consistency of peanut butter. Now, as you see my example here, if we're on the side of Pacaya, peanut butter is running, you can start to see it oozing down, running a lot slower. Now, it does go faster than this because this is just a little bit of peanut butter. You have to imagine if you had, you know, just oceans full of peanut butter behind itself. The peanut butter is heavy enough to push it down. But when it gets to a flat slope or a slight slope or a flat area, it moves really slowly because it's like peanut butter. And you can do this experiment. Maybe you guys can do this experiment in school. You can take a board, put it at a 45-degree angle, put honey on one side and peanut butter on one side, and have a race. Which do you think will win? I think the honey will win. And so that's why they had time to move it, is because that lava moves a little bit slower in this part of the world, or around volcanoes, around the Ring of Fire, like we have in Guatemala. All right, so we're going to go back to our lava fields here. And so we just saw the lava store. When we look back up at Pacaya, this is the caldera. So inside the caldera there's actually, so this is like the crater up top here, and inside there's actually a little place where the lava comes out. So there are like little places where sometimes it'll splatter up, but in here is a new cone that is growing. One day it may grow up big again, and until there's a very large eruption. When there's a large eruption, that top will blow off, and that's why it has a crater or a caldera on the top of it, and not a cone shaped. And you can see, if you look close enough, you can see it's kind of hard because it's a hazy day, but there's fumes and gases. So not only lava, but gases and ash will come out of there as well. Fumes will come out all the time, but especially during an eruption is when that ash will come out as well. All right, so we're going to hike down into the lava fields. Be careful. You can see the slope is steep here. And, there's no hand railings as we look back up at Pacaya. And the rock is loose. All right, so now we're down into the lava field. So all of this black stuff that you see in front of us, this is all hard lava rock. Lava cools really quickly, by the way. Especially around the edges or the outside of a lava flow, like on the top, the crust of that lava flow. And when we get down to here, you'll see where some places where it built up really high. So it stacked up really high. We're going to see one of those places right here. As you can see, I am 6 foot 1 inches tall. So if I draw a line here, you can kind of see it stacked up really high here, really big stack of lava. And I have a question. I think I know the answer here, but do we have any fans of pizza today?
Oh, yeah.
Yeah. Do you guys like pizza parties? Yeah. Okay. So when you go, all right. So when you go to a pizza party, what do you guys think? I like hot pizza. Do you think the bottom pizza has the hottest pieces of pizza or the top pizza? The bottom pizza has the hottest pizza. And the reason it has the hottest pizza is because all this pizza on top, it's insulating the pizza on the bottom. Okay, that means it's trapping the heat off. It's not losing heat to the air. Same thing is happening right here. So deep down in there is like our bottom pizza. So it stayed hot in there. Remember, this lava is from 2010, or sorry, 2010. It's 2018 now. It's still warm enough. Okay, it's still hot down in there, deep inside there. And because of that, you can do pretty neat things with that heat. Remember those sticks we were cutting? Did anyone have any guesses over in Georgia? What did you guys think? Did you have any guesses what we're going to use those sticks for?
Today. So you can catch the fire in the
right? Maybe make a fire. Well, I'm thinking of something we do over a fire sometimes. Anyone ever roasted marshmallows before?
Yeah.
Check this out. So we're going to use those sticks. We can still roast marshmallows with lava from 2010. And the reason we can do that is because we have a big old stack of lava, and deep inside there, it's still hot. So there's still some pockets of heat where that heat is coming out. And look at there. There's your visual proof, guys. You know, virtual field trips are awesome. Unfortunately, technology, I can't pass you guys a roasted marshmallow. So you'll just have to go here and do it yourself one day. And if you want those marshmallows, but take graham crackers and chocolate with you because we didn't have those to make s'mores. All right. So not only can you roast marshmallows, but you can also heat up your lunch if you had lunch with you. And I had lunch with me. So I took opportunity to heat up my sandwich. And so this is just a great example of how the community, remember I told you they were made those earth ovens, and this is how that process works is you have heat coming out of the earth, not only close to a volcano like here, but the heat is always coming from the earth. So if you dig, especially close to a volcano deep inside there, a hole, you can get to that heat. All right, we're going to walk across the lava field here. Don't worry, it's hard enough. We're not going to fall in or anything. And lava rock is really hard, by the way, and it's really sharp. So I recommend that you come here, you bring a good boot with you. And we're going to head over to the lava store and check it out. And here's the lava store. What's unique about the lava store is it's a great way to support the local community and locals, people that live on the volcano. And so there's local Maya people that come here and they take lava rock and they make jewelry out of it. And so you can actually buy, you know, things for your parents. And speaking of buying things for your parents, guys, explorers, don't forget, Mother's Day is coming up this weekend. Don't get in trouble now. And so there's the lava store, and made from lava from Pacaya, our stratovolcano there. All right, so as we hike up out of the lava fields, we'll show you one last thing off in the distance. I have another thing to show you once we get up on the ridge. As I'm doing this, take this time to go ahead and start sending in your questions, especially our classrooms that are off camera today, and use the Q&A app or hashtag GeoShow on Twitter. But right down here, this is not another community. This is actually a power plant. And that power plant makes something really unique. They make something called geothermal electricity. And that prefix geo, just like we're watching the Geo show, geo means earth. So geology is a science class. Geology means study of. So geology is the study of earth. Geo show, the earth show. And if we have geothermal, so thermal means heat. So geothermal electricity. So what is geothermal electricity? What do you guys think over in New Jersey?
I got one.
Question? Wait, what? Go ahead. Go ahead, ask your question. Stand up. Go ahead.
All right, we'll come back to you in a question in a second. So geothermal means heat from the earth, so they can make electricity from the earth, which is really cool. It's really clean type of electricity. All right, and here we go. And this is a lava rock up close. It's really sharp. It hasn't had time to become weathered. Can you guys say weathering?
Weathering.
Weathering is like erosion for rocks. So it's the process of rocks going from sharp, like we see here, to really smooth. If you've ever found a river rock before, you know how smooth it is? Well, that's because that water running over it over long periods of time can smooth these sharp rocks down. But when it first cools, it cools really sharp. Again, it's still hot enough. And this is gross, I know, but when I took my boots off, I just wanted to prove to you guys how dirty and you can get from all the ash. So all this ash that's still in the soil, it's really good that all that ash, you know, I didn't really talk about it, but we see the ash coming out of an eruption here. This is the 1976 eruption. And all the ash coming out, when it falls down on the ground, it really makes, you know, we get a question a lot, why do people live on volcanoes? And the soil is really fertile. So it's really good for growing vegetables, growing fruits, and those things. And again, the last major eruption, even though we saw the 2010 lava, the last major eruption was 2014. So we're going to open up the floor for questions. Before we do, I know we're going to get this question, so I'm going to go ahead and play it. And I asked someone that lives on a volcano, is it scary to live on an active volcano?
Well, my name is Fernando. I'm from Guatemala City.
And where do you live now?
I live on top of an active volcano. It's called Pacaya, Guatemala City, Central America.
And are you afraid to live by the volcano?
No, at all. This is such a beautiful place that I invite everyone to experience this beautiful energy of the volcano.
What do you want to do when you die?
I want this day to spray my ashes on top of the volcano.
Yeah.
This is a very special place for me.
And how long have you lived in?
Live around the volcano for 5 years.
5 years?
5 years. Matios. Matios means thank you in Maya language.
All right, can you guys say Matios? All right, so that means thank you in the local Maya language around Pacaya. So there are about 29 and 32 Maya languages. So they're different ones, but Matios means thank you in this local one. All right, so we're going to go ahead and jump right into it, start answering some questions we have coming in. Mrs. Gullo's classroom, do volcanoes erupt at a certain time of year? Coming from Mattawan, Michigan. So they can erupt all year round, and they are consistently erupting. So if you go, a great place to go and get information about volcanoes and when they're happening, earthquakes too, is the USGS. It's the U.S. Geological Service, and they have maps, interactive maps of volcanoes that are currently erupting all around the world. And also we need to think, when we talk about volcanoes, remember earlier we said plate tectonics, and the bottom of the ocean has plates. Well, the bottom of the ocean also has volcanoes. And just how most of the earth is covered with ocean, well, most of the volcanoes are actually below the ocean. So about 80% of all volcanoes are underwater. Mrs. Pohl's classroom, Jessica asks, sorry, how do you know if a volcano has potential to erupt? So there's different tools, such as the USGS use. Let's say in Hawaii, for example, they use things like, well, one is earthquakes. There's earthquake activity rises. So seismometers that measure earthquakes, they use those. They use GPS and tilt meters. So what they do is they install GPS and tilt meters on the sides of volcanoes, because when a volcano, when the reservoir inside the volcano starts to balloon up, and we can do this because, you know, we've been sitting for a while. So everyone, let's loosen our shoulders. We're going to take our magic balloon here, and let's blow up our balloon. And what happens when we get too much air inside that balloon? It pops, or in the case of a volcano, it doesn't pop, it erupts. And the same thing happens to that balloon. In the balloon's case, it's air is where that pressure is coming from you blowing air in there. So in a volcano, instead of blowing air in a balloon, think of magma coming from deep inside the earth that is pushing magma into that volcano. And after enough pressure inside of there. It can get enough pressure. Well, that volcano will actually balloon out. So as it balloons out on the sides or slopes of the volcano, if you have GPS and tilt monitors there, you can measure that ballooning. And so you can tell that it's becoming bigger. It has a higher potential to erupt. And then they also use satellites as well, that where they can read with radars, hot spots, magma getting close to the surface, for example. So these are all just different tools in the toolbox to study and monitor volcanoes, but it's not an exact science. Remember, an active volcano can be one that erupted 9,000 years ago. So we can't tell. We can say it's getting close or it's becoming more active, but or more unresting, but we can't say, hey, it's going to erupt tomorrow at 3 o'clock. So we're just not there yet. Great question there. And Mrs. Romero's classroom wants to know, how many volcanoes have I visited? I visited volcanoes in Indonesia, Japan, and Guatemala, but they're all different sides of Pacific Ocean, but all on the Ring of Fire. Okay, we're going to go to our own camera guests now, and let's start over in Anaheim. Do you guys have a question for us? We're going to go to New Jersey next, so if you want to come up to the camera. Go for it.
Can a volcano, like lava, when it explodes, can it flood a whole entire city?
Yeah, I mean, if that city is close enough, it could definitely flood their entire city. In the case of Guatemala, typically the cities are a little bit far enough away that it's not going to flood. It's not going to get there because it's flowing like peanut butter. It's going to cool before it ever gets there. But with the case with this peanut butter, it also makes more violent, more explosive eruptions. So it could shoot lava through the air, sometimes the size of a car or a refrigerator. So yes, if you are close enough, you could get hit by flying lava, and that's scary to think about. Let's go over to New Jersey. What's your question?
When a volcano is about to erupt, does the stuff around it shake?
Right. So one of the telltale signs for eruptions is an increase in earthquake activity. So around those volcanoes, you'll see an increase of earthquakes. And this is what's happening right now in Hawaii. So in Hawaii, we're getting a lot more. That's what's called Kilauea, by the way, just didn't start erupting last week. The activity increased dramatically, but Kilauea has been erupting since 1983. So for the past 35 years, Kilauea has been erupting constantly. This is just other spots, new spots where earthquakes have caused fissures into the earth or cracks into the earth. And now lava is coming out of these new cracks, so new spots. But there's been an uptick in earthquakes. Okay, let's go over to Georgia.
How is the magma formed?
Right, so magma comes from, or it's molten rock. So it comes from, it's a cycle. We can think of rock cycles. So just like, the best thing to think about is water, right? So you have 3 states of water, or any substance really. You have a gas state, a liquid state, and a solid state. So when we get water cold enough, it becomes ice or solid water. We call that ice, right? So when if we go the other way, if we get ice hot enough, it melts and becomes liquid water. Okay, same thing with rocks. We take a hard rock, we get it hot enough. It's a different temperature now. It's not 0 degrees Celsius or 32 degrees Fahrenheit above there. This is very hot. If you get it hot enough, you're going to take that solid rock and it's going to become molten magma. So it's going to become liquid rock. All right, and when it cools, it's going to go back to a solid state. It's going to go back to a rock. So that's how it forms. That's where we get magma from, is the melting, and we get the rock from the cooling of the magma. All right, great questions coming from all around. And over on Twitter, Mrs. Whitcomb's Adrian wants to know, what's the biggest, most active volcano right now? I think on the Earth's surface, is the biggest volcano is Mauna Loa, if I'm saying that correctly. That's next to Kilauea, but the biggest volcano on Earth is actually at the bottom of the Pacific Ocean. It's way bigger than that one. And let's see. Also, we'll do one more from Twitter. And let's see, Mrs. Masslerner's classroom. What is the temperature of lava rock? I know I'm butchering that. Sorry. Lava rocks where you're able to roast marshmallows. So the roasted marshmallows, that it was actually just kind of think of like a hot hair dryer. It was just fumes or heat coming out of pockets of heat, hot spots on that lava rock. So it was warm enough to heat a marshmallow or roast a marshmallow. But when it first comes out, it's a lot hot. It's over 1,000 degrees Fahrenheit in Guatemala. Okay, so really quickly, we're getting late in our show. So we do just want to show you really quickly Antigua. Antigua is the old capital city. They moved the capital city in Guatemala from Antigua because of all of the earthquakes and volcanoes. In fact, there's 3 volcanoes that surround Antigua. And as I'm telling you about them, just by the way, technology is great when it works. If you guys are not seeing anything and you only see me right now, just let me know in the chat box and we'll restart it. But Volcan Agua is right beside the city. Classic stratovolcano. So if you know your Spanish, taking Spanish class, that's water volcano. And next to Volcan Agua is Volcan Fuego, which is fire volcano. This one is extremely active. It hasn't had a major eruption in the past year or so. Since 2017, but it does go through times of extreme activity. That's why you see there's no vegetation growing up around it. And Volcan Acatenango is right beside there. Volcan Acatenango is 13,045 feet. It's actually part of the same system as Fuego. You can see they're right side by side. Now we're going to see someone really quickly walk on the gneiss ridge that connects these 2 volcanoes. So the gneiss ridge is located right here. So this going right here is called the gneiss ridge that connects Volcan Acatenango and Volcan Fuego. I did not personally go up here, but I met a man that goes up here often, that runs expeditions up here, and he lent us this to share with you guys today.
This is the spine of the beast, Volcan Fuego, one of the most active volcanoes on planet Earth. Right now we're walking on what we call the knife ridge. You've got about 1,000 feet drop on this side, 1,000 foot drop on this side. This is a gnarly place to be. And if you look up ahead, you can see the very active cone. Sometimes it just blows. No warning, you just duck and run for cover.
September 13, 2012. The 12,500 foot tall Fuego explodes, blasting lava rocks and ash thousands of feet high, and forcing the evacuation of 30,000 people from the villages surrounding the nearby city of Antigua.
If you can imagine this entire cone blowing apart, it shoots huge chunks of lava rock, sometimes the size of cars, straight up into the air, thousands of feet over your head. This is a belt from the guts of the earth.
All right, and that is Volcan Fuego. And Volcan Fuego is very unique because it's so active. Scientists, volcanologists study Volcan Fuego a lot, and they're using a cool piece of technology to study it. And I want to know from you guys, what do you think that technology is? So if you grab your Kahoot devices, this is our last survey question, and we're jumping right into our quiz. So make sure you get logged in. 228-3145 is our game pin. So what are scientists using to get close to Fuego's eruption? Are they using helicopters, jetpacks, drones, or hang gliders? All right, they're actually using drones. This is really cool. If you want to see this process, I recommend that you all go to flipgrid.com/GEOshow. our Volcanoes board. I have a YouTube video link there. You can see this drone footage getting right up close to the eruptions of fuego. It's really cool. And it's really awesome that we're able to use technology to stay out of harm's way of these eruptions to study volcanoes. Okay, we're going to jump right into our geo quiz. We're just past 45 minutes. I know some classrooms need to run. So we're going to go ahead and play that, see how well you were paying attention. And if you have time to stick around afterwards, I'm going to open it up for a lightning round of questions and answers. We'll get to as many as we can before I have to go. All right, so go ahead and grab your devices. Again, every question from here on out is worth points. The quicker you answer correctly, the more points you are awarded. Here we go. Good luck, explorers. What is the major cause of volcanoes along the Ring of Fire? Is it Mother Earth is angry, supernatural causes, hotspots, or subduction? All right, is this subduction? Soaring Goose takes the lead. How many volcanoes are surrounding Antigua? 3, 2, 4, or 1? It's 3 volcanoes, Agua, Fuego, and Acatenango. Rapid Raven. When was the last sizable eruption on Volcan Pacaya? 1978, 2010, 2014, 1964. All right, it's 2014. Great job. Jelly Penguin takes the lead. A volcano that will never erupt again is called a extinct volcano, an active volcano, or a dormant volcano. Right, it's known as an extinct volcano. Great job. Is Guatemala located on the Ring of Fire? Yes or no? What do you guys think? Last one, make it count. All right, yes, it is located on the Ring of Fire. Today's winner is dun 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 dun, Jolly Penguin. Congratulations, Jolly Penguin just won the last Geo quiz of the school year from the Geo Show. And if you're Jolly Penguin's teacher, please make sure you send me your school address so I can get that postcard sent out to your little penguin. And you can do that over at learnaroundtheworld.com/prize, learnaroundtheworld.com/prize. Just stick in your snail mail address and I'll send it right out to you. For everyone else, if you have to head on, have a great day. I hope you take this opportunity to study and research volcanoes more. They are super duper cool. If you have time to stick around, we're going to start answering questions. So send your kids up to the camera or keep those questions coming in. Let's see. Mrs. Manser's classroom wants to know, what temperature is lava? Emily asked. Well, lava can get over 2,000 degrees in Hawaii, but in Guatemala, typically around 1,400, 1,600, a little bit less in their temperature. Okay, let's start over in Anaheim. Go for it.
Does the volcano get smaller or bigger if an earthquake happens?
If an earthquake happens?
Can a volcano get smaller or can it get bigger in an earthquake?
Well, depends on several things can happen, right? So parts of, say what happened with Kilauea. With Kilauea, part of it collapsed, which helped create part of that crater lake and different other craters. So you can, if you think of collapsing into a crater, it can technically get smaller. But or inside of the volcano, what can happen with earthquakes is those reservoirs that are holding magma, sometimes they can start to lower. So for instance, in Kilauea right now, that lake is actually getting lower. That lava is going off, being diverted, or sorry, the magma to different areas. And you kind of have to think of it. It's not a perfect, remember the illustration, we have one vent coming up into a volcano. It's more like a very complex pipes, like plumbing system, that all of these canals and vents that have magma going through those big, massive volcano systems. Great question. Let's go over to New Jersey. Do you guys have another question?
Okay, I'm gonna leave them. Oh, question. Come on.
Yeah, go for it.
How many times a volcano erupt in a year?
How many can one erupt in 1 year? Again, I know you guys are going to hate this answer, but it depends because when we look at Kilauea, for example, it's been erupting constantly for the past 35 years. So technically that's one eruption, but that's a lot more lava coming out of there than another one, for example. But if we look at, say, one we saw today, like Fuego, Volcan Fuego, for example, although it's been pretty sleepy the past year or so, there were a couple of months, 2-3 years ago, where it was erupting almost daily for about a couple month period. So that's lots of smaller eruptions, for example. When I was in Guatemala, I saw Fuego erupting from Antigua. It was a smaller eruption, but so if you're counting all the small ones, the number can get quite high. Great question coming from there. Over on Twitter, we have, let's see, at Teacher Fifth, Mrs. H, or let's say Aubrey wants to know from Anaheim, which volcano is considered the most dangerous and why? I would probably say any that's closer to larger communities. So probably out of the ones we saw today, maybe Agua or Acatenango or Fuego, one of those, because they're just closer to a lot of people. Pacaya is probably more active with larger eruptions, but it's kind of in a more rural area. So it's more dangerous if more people live there, right? So let's go back over to Mrs. Worski's classroom. Go for yours.
My name is Ashanti, and I want to know if anybody has ever touched or stepped on lava.
So yeah, you wouldn't want to do it on purpose, right? I imagine people have at times become hurt. So one thing, what's so good about using drones or robots, for example, for studying volcanoes, is volcanologists have in the past, and they still do it today, they put on these special suits, if you've ever seen it like on TV, and they put on these special suits to get really close to the lava, to even take samples of lava. In that case, it can be extremely dangerous if that crust collapses in to maybe a pool below there. So yeah, so it can definitely become dangerous. I don't know of any specific examples of someone actually doing that, but I'm sure it's happened to someone throughout human history. Great question there. We also got coming in, let's see, we have Mrs. Marcia's classroom wants to know, or they are heading out, I should say. Anonymous wants to know, can volcanoes in cold places, can they be in cold places like Antarctica? So yes, they can be in cold places. I don't know specifically, just because I haven't looked into it really. I imagine there's some in Antarctica, but if we think about the Arctic, for example, places like Greenland or Iceland is a very, Iceland, don't be fooled by the name, doesn't have as much ice as Antarctica or even Greenland, but it's a very active area with volcanoes. So if we look north, we can find them there as well. Let's see, was there any animal life in the lava fields? Coming from Mrs. Ramirez's classroom. So I saw birds. When you study or look at people that have studied life, you got to look more at the soil. So there's some places in South America where they have found bacteria, fungi that has lived pretty close to calderas in the soil, which is a really harsh environment, especially when it's a very active volcano of constant eruptions. But when we think about life near volcanoes, it's better to look below the water, below the sea. So when we think about under the ocean, there have been many animals that have adapted to living near that really hot water caused by these underwater volcanoes, things like barnacles, even shrimp, smaller animals as well, much smaller, and then even as large as sharks. Some sharks have been seen in calderas as well, deep below the earth. Okay, or below the ocean. Let me go back over to Anaheim, Mrs. Worski's classroom. Do you guys have another question?
Are there any other active volcanoes on other planets?
On other planets, yes. There would be volcanoes on other planets. I don't know a lot about volcanoes on other planets, but this is a great point to be inspired and go out there and research it yourselves. So that's what we like to do here on the Geo Show. All right. Also, we have coming in over on our Q&A app. Let's see. We have a question from, let's see, someone is still here. Josie wants to know, when did you get interested in studying volcanoes? I've always I've always loved science, and geology was one of the first classes that really got me hooked on science. But really, I mean, with GeoShow, so visiting Guatemala, and really started to really dive in and do a lot more research into volcanoes. And I used to teach science as well, so I used to teach a lot about earthquakes and volcanoes and rocks. Okay, let's go back over to Mrs. Worski's class. Looks like you got another question. Go for it.
Okay. Hi, Maiden. What happens to extinct volcanoes once they become extinct?
Well, it's just like an empty. Think of a vacant house, right? So no more people are living in that house. The house stays there. There's just no people inside of it. So in this case, think of a volcano and magma. So the magma is no longer present inside there. So most of those 37 volcanoes, or not, I don't want to say most, but a lot of those volcanoes are extinct in Guatemala. They're still there. You can hike up them and you can look at them just like we looked at Pacaya. The only difference is there's no more magma coming up into the volcano. So there's no potential for it to erupt again. All right, great question there. Over on Twitter, we have, let's see, Renee wanted to know, was there a first volcano that erupted in Guatemala, and how many volcanoes are actually discovered there? So there's 37 there. The oldest one that I'm aware that I did my research on was Lake Atitlan. Is a big lake. It's an old crater lake. That lake that crater formed 84,000 years ago. But even then, that's not very old in Earth years. Okay, let's go back to Mrs. Worski's classroom.
I'm Joshua, and what's the difference between volcanoes underwater and on land?
On land and underwater, right? So not much as far as like the actual mechanics of it. It works the exact same way. The only difference is when it erupts, it's underwater, right? So that lava is going to cool a lot quicker underwater than it is going to be on top of land. Now we can think about this, the entire, when we talk about plates, remember our example, subduction zones that are ramming into each other? Well, a great example of this is in the middle of the Atlantic Ocean. You have two plates that are moving away from each other, and the Atlantic Ocean is actually getting bigger. And because the Atlantic Ocean is getting bigger, because where those two plates are moving away from each other, lava is coming up and replacing where those plates are moving away. So it's creating more crust. And so those two plates are getting larger and larger and larger and larger. So if you look at any of you familiar with Pangea, when all the continents were together and now they're moving apart, well, that's that process. Those plates that are moving apart in the middle of the Atlantic is making North and South America get further and further away from Africa and Europe, for example. Great question there. All right, so looks like we have a late joiner. Sorry for you guys, but we are at the end of our program. And for everyone out there, thank you so much for coming along with us to Guatemala to look into and research volcanoes on our virtual field trips. Go out there, explore volcanoes more, and also don't forget, it's a great big world out there. I'm GOB. You've been watching the Geo Show, so keep exploring, guys. Until next year, keep exploring. Bye, guys.
Bye.